Welcome back. Before we delve into the study of Blender, I would like to try to talk a little bit about theory. Maybe I will say some jibes, you will forgive me. However, my intent is to make you understand some basic concepts. At some point, if I remember correctly, around 1600, a French philosopher whom we now call Descartes posed the problem of being able to reproduce a series of points on a plane in an unambiguous way. Let me give you an example. How can we do to uniquely reproduce the position of these points? The idea that came to Descartes was to create a system of reference, a kind of diagram precisely called today a Cartesian diagram, that would make it possible to transfer the graphical information of these points into numerical information, so that at any time we could reproduce the pattern that we, for example, see right now on the screen. How did Descartes do this? He assumed that he plotted two axes that form the reference system, a horizontal one that we today call the x-axis, and a vertical one that we call the y-axis. He then determined that the point where the axes intersect is the origin and established that the numerical succession be placed on these axes. For example, along the x-axis we have 1, 2, 3, 4, 5 and so on. And same thing for the y-axis, going in the direction of the arrow, so upward. We have 1, 2 and so on, and going in the opposite direction, obviously we have negative numbers, so 1, 2 and so on. What did he succeed in doing by creating this very simple coordinate system? He succeeded in allowing people to find the location of points A, B, C, etc. using numbers. For example, point A right now is at point 5 on the x-axis and point 4 on the y-axis, so the coordinates 5 and 4 are the coordinates of point A. B, on the other hand, will be in coordinates 7 and 3. C will be in coordinates 2 and 4. Consequently, we can transcribe on a piece of paper with coordinates 5 and 4 the point A, point B with coordinates 7 and 3, C with coordinates 2 and 4. There you see I transcribe on a piece of paper these coordinates, and I can at any time, even after a long time, redraw the triangle ABC, or at any rate the position of A, B and C. This simple trick, let's call it that, was a groundbreaking thing. Without this, science today would be stuck in the Middle Ages. Thanks to Cartesian coordinates, it was possible to create the graphics we know today. Just think that every single pixel shown right now in the monitor has an X and Y coordinate. Here, in a very poor way, this concept is the same system that we find in Blender today, with the difference that we are not only using the X and Y axis, but also the Z axis, because we are not working on a plane, but we are working on a space. So the directions of movement are not only X and Y, but also Z. In Blender, this axis is colored blue, so the three colors red, green, and blue, always remember that, correspond precisely to the three axes. Generally, the Z-axis is the one that is perpendicular to our plane. So also imagine the world around us. If we drop a ball on the ground, lo and behold, this ball will move along the Z-axis. Said in a very simplistic way. But let us now turn to Blender to go and learn about the three-dimensional space of the 3D viewport together. Let's first look at the X and Y axes. We have just seen them. The red one is the X-axis, the green one is the Y-axis. The Z-axis is by default not displayed, however we can meanwhile see it here in this manipulator that we find at the top right. You see the Z-axis is colored blue. And if we want to visualize it inside the viewport as well, we can go inside the overlays menu, which we will learn how to use over time and which we find here at the top right. You see that the axes displayed are X and Y. If we click on Z, it will also appear. Before we go on and see together how we navigate within this three-dimensional space, let's take a look at what objects are present by default in the scene when we open Blender. In addition to the axes, we see a grid that represents the XY plane and consists of this gray mesh that allows us to have the perception of a kind of floor on which we are standing. Again, in the spirit of broad customization of Blender, we know that we could eliminate it, hide it. However, we during the course of this course will keep it. We see that there are three distinct objects. The most conspicuous one, and also the most famous one, is the cube. The default cube. It is this object that is exactly in the center of the scene, and is located right at the origin of the axis, i.e., where the X, Y, and Z axes intersect. In addition to the cube, we find the camera, which is this pyramid-shaped object with a rectangular base. The shape we will see that reflects the format of the image that we are going to produce, in this case a 16:9, and we see in fact that the base of this pyramid precisely has this ratio. And then we have this little gray dot that is a light source. Finally, I want to point out the 3D cursor, which is also in the center of the scene inside our cubie, and it is this little red and white circle. We will see in the continuation of the lessons how the 3D cursor will be very useful as a reference system, as a support point, a kind of anchor for our commands, the insertion of our meshes, or as a point of rotation, point of scale, of transformation. We'll see it together later, but inside it we also see a little orange dot. Here, this orange dot is the origin of the cube object. Every object has its own origin, and the x, y, z coordinate of an object refers to it, but we will come back to that later anyway. What I would like to talk about today is actually how we can navigate within our 3D viewport. Here at the bottom left you see a mouse icon. In your version of Blender it probably doesn't appear because it's not there by default in Blender, and it has to be activated because it's a separate add-on called Screencast. I activated it for you to show you what buttons I press. Well, how do you navigate within the 3D viewport? The first thing we have to consider is that to work well with Blender, it is important to have a classic 3-button mouse, also very cheap, but it works very well. It has the right button, the left button, in the middle the wheel that can be both rotated and squashed. Let us perform together the first operation of navigating within the 3D viewport, namely zooming. To move closer or farther away from the current viewpoint, we have to use the mouse wheel, so we have to rotate it forward or backward. You see the cube and other objects move away and move closer precisely in applying this rotation. The exact same effect can be obtained by clicking on this magnifying glass icon with the plus. Try it, click and drag back and forth. You see that it is very easy to perform a smooth zoom. Much smoother than with the mouse wheel, a little less fast perhaps. However, it allows us to perform much more precise movements. In addition, the presence of this icon allows us to zoom in even if we are using, for example, a graphics tablet with a pen. Instead of using the mouse wheel, we can go and click on this icon, and then we can drag the pen back and forth to zoom in. Another operation for navigating within the 3D viewport is to rotate the view. To do this, we always use the center mouse wheel, but instead of rotating it, we click it. We then click and drag to see what happens to our viewport. Here we see. We start to rotate around our cube, and it is a very simple operation that will become more and more natural for you over time. As with zooming also, the rotation of the scene can be done through these icons that we find on the right in particular. Here we go to use this manipulator consisting of the 3 axes X, Y, and Z. If we go to click inside this circumference, we are going to perform a rotation very similar to the one we would have by clicking on the center mouse wheel. Another very important operation, on the other hand, is panning, which is a movement parallel to the view we currently have in the monitor. To perform this operation, you have to hold down the Shift key on the keyboard and then click on the mouse wheel and drag. Let's do it together. We hold down the Shift key, click on the wheel and drag. You can see that we can now move our viewpoint right, left, up, down, parallel to our monitor. Same identical operation we can have by clicking on the hand icon. We left click and drag. The effect is identical. The combination of these 3 types of movement allows us to navigate within the 3D viewport. For example, if we want to view the top face of the cube more closely, we can first rotate the view so that we are positioned higher, then we can use the wheel to zoom and the pan to center the view. Do this as well. A good exercise is to go and visualize all 6 faces of the cube. Let's try, for example, going to visualize this other face, this one, the bottom one, and so on. Do this as an exercise because it is very important. Within the 3D viewport, we also have the ability to visualize three-dimensional space in two similar but different ways. Let's look closely at our grid. These lines that travel parallel to the x-axis actually converge to a single vanishing point. This is a view called a perspective view, and we know that we are using this type of view not only because we have precisely this vanishing point, but Blender also tells us here in the upper left-hand corner, we are using a user perspective view. User means it's not a predetermined view like top, bottom, right, and left, so it's a free view. And perspective means it is in perspective with vanishing points. This is a friendlier way of viewing 3D space for us humans because everything around us, we actually see it with a perspective view. In contrast, we may want to see our scene with a parallel projection, that is, without vanishing points. To get this kind of view, we can press the 5 key. Here, something has changed. There are no more vanishing lines. You see that the cube has taken on a somewhat strange shape, somewhat less realistic, because precisely it is a way of visualization typical of technical drawing. It reminds us very much of what we experienced in our middle school years, and also in our 2-year high school years. However, even though it is a parallel view, no one prohibits us from performing rotations, zooming, and panning. Let's also look at the top left here. You see the wording has changed. It says user orthographic view, which means precisely an orthogonal graphic, with lines parallel to each other and always preceded by the writing user, which means point of view different from the standard ones. To switch from orthographic view to perspective view, you can use precisely the 5 key on the keypad, but you can also use this icon that we find here on the right, the lower icon. If we click, we go to the perspective view. If we click again, you see that the icon changes to go to the orthogonal view. We talked about user type views, that is the user view, but what are the default views instead? The default views are the top, bottom, right, and left views. How do you switch to one of these views? You use the numeric keypad. This is why I strongly recommend that you have an extended keyboard, the one that has right next to the classic keyboard also the numeric keypad. Because by using this keypad, we will have the ability to switch very quickly from one view to another. Let's look together at the 8, the 2, the 4, and the 6 form a kind of cross. With this cross, we can perform rotations with standard steps. Up with the 8 key, down with the 2 key, left with the 4 key, right with the 6 key, so we can rotate in predetermined steps. But the most important keys, however, are the 7, 1, and 3 keys. The 7 key will take us to the top view. Look at the top left. Now we see that we have switched to the top view. We are no longer in the user view, but we are in the top view, that is, from the top. And at the same time, we have switched to the orthographic view. Now I'm going to click with the mouse wheel and go to any position. I am back to the user type perspective view, i.e. any view. If I press the 7 key, let's do it together again. We go to the top view, that is from above, and it is also orthographic, so we see our cube with a parallel projection seen from above. With the 1 key instead, we go to the front view. The front view, you also see that they change the colors of the axes that are displayed. In this case, we are seeing the x-axis and the z-axis, while the y-axis we do not see, because it is actually perpendicular to the monitor, so it is coming toward us. With the 3 key instead, we switch to the right view. Well, how, however, to switch to the bottom view, for example, we can use the Ctrl combination to go to the opposite view. So if I press, instead of the 7 key to see the top view, I can press Ctrl plus 7 to go to see the bottom view, i.e. the view from the bottom. Just as with the 1 key, I go to see the front view. With Ctrl plus 1, I go to see the view from behind. With the 3 key, I go to see the right view. With the Ctrl plus 3 key, I go to see the left view. So we have seen what the 8, the 2, the 4, the 6, the 7, the 1, and the 3 are for. We are missing the 9. What is the 9 for? Well, the 9 is for looking at the view opposite to where we are right now. So now we are looking at the left view. By pressing the no key, we will be at the right view. If we are in the top view, by pressing the 9 key, we are going to see bottom. That is the view from the bottom. Even if we are in any view, by pressing the 9 key, we are going to see the opposite view. So at any time, we can view our object from side to side by pressing the 9 key. If we don't have the numeric keypad, apart from the fact that we can emulate it by going into Blender's preferences, we still have the option of using the rotation manipulator here in the upper right-hand corner. For example, to position ourselves in the top view, we will simply click on the letter Z. So to switch the right view, we will click on X. Front view on Y, and consequently to see the opposites, we will go to click on X, Y, or Z. Again, we see how this is very useful for those using the graphics tablet. We continue to see the keys made available on the numeric keypad. We have the 0 key, for example. With the 0 key, we can switch from the current view to what the camera is seeing. Let's do that together. Here is that the frame has moved to the point of capture. You see, this clearer rectangle is what will be produced by the final rendering image. We will see that, of course, later. By pressing the 0 button again, we go back to the previous view, and this operation we can of course also do with the camera icon that we find here in the menu on the right. So by clicking, we can switch from camera view to normal view. Again, this is very useful for people using the graphics tablet. We have seen that in our scene there are these three objects: the camera, the cube, and the light source. I am now selecting it. To select, we'll see it anyway from the next lesson. You can use the left mouse button. But when I select, for example, the cube, we notice that something also happens in the outliner here in the upper right corner. You see the cube, once a 3D viewport is selected, it is also selected in the outliner. Same thing, if we select an object in the outliner, it is also selected in the viewport. Why am I showing you this at this time? Because there is the possibility of using the Maintain key on the numeric keypad, the one to the right of the 0, to go and view the selected object. For example, we are lost in the 3D viewport. Here, I deliberately zoomed in. You can't see anything anymore. The cube, who knows where it went? Although we actually have the 3D cursors helping us out, but we want to go and see on the fly where our camera went. We click on it in the outliner, then thanks to the keypad, specifically the A key, let's press it together. There we are shown the camera immediately. That is, a zoom is performed on the selected object. This can also work on multiple objects. For example, if I select the object cube and light at the same time, I press the comma key and the zoom goes to move so that we see these two objects. This is most convenient, especially when we find ourselves in difficulty in doing the test that maybe you find yourself zooming in, but this thing doesn't seem to work. You get lost. Here, don't be afraid. At any time you can select an object. For example, in this case, I selected the cube by pressing this here. We find ourselves focusing our view on the selected object, and then we can start again by zooming, moving, and rotating the view. With the blaz and the keys, we can zoom in and out. So completely analogous to what we can do with the mouse wheel and the magnifying glass icon. Benem, before we leave, I propose an exercise that for many of you will be very difficult. However, I really encourage you to perform it because it is very, very important to become familiar with navigating within the 3D viewport. You will find in the description of the video, in addition to the link to the handouts that I invite you to download if you are pleased to support the publication of the lessons, you will also find the link to this object, a Blender file that you can freely download to train yourself to navigate within the 3D viewport. You will actually have to go into it and go find 3 sentences that I have written for you. So the challenge of this exercise is to go in and frame these 3 sentences with the 3D viewport. I'll show you one of them. Here it is. 1. Apply the scale. For the time being, this sentence does not tell you anything, but I promise that in future lessons it will take on a very important meaning. Go find the other 2 sentences as well. It will be a great exercise. I, as always, thank you for following me, and I will see you again soon.